Welcome to this tranquil space where curiosity can meander and science unfolds at its own pace. Tonight, we embark on an extraordinary journey, stepping far back in time, so far that even the ground beneath your feet transforms into something unrecognizable. We are venturing into an Earth that existed hundreds of millions of years ago, long before cities rose, before oceans took on their current forms, and even before the world began to resemble the maps we know today. This is the tale of Pangea, a colossal continent that once spanned much of our planet, uniting nearly all the land in one vast expanse. Many have heard the name Pangea, perhaps tucked away in school textbooks or whispered in documentaries. Yet, how often do we pause to envision what life was like then? What sights would greet you if you could stand upon that ancient land? How would it feel to inhale the air of a time untouched by human hands? Imagine walking across a landscape devoid of familiar borders and gazing up at a sky that had yet to be defined by the geography we recognize today. To truly grasp this world, you must release the mental map you hold. There was no Atlantic Ocean separating the Americas from Europe and Africa. Instead, envision a land where everything was interconnected, a single sprawling expanse inviting exploration and wonder. Imagine a time when the vast Pacific Ocean does not divide the globe. Instead, envision a single continuous landmass. If you could walk across it, you would start in the northern part of present-day North America and journey east, seamlessly crossing into what we now know as Europe and Asia, never once stepping onto a ship. You could choose to turn south, moving into Africa and South America, all without witnessing an ocean on the horizon. This world is a sprawling expanse of land, stretching far beyond what any traveler could cover in a lifetime, encircled by a vast ocean that hugs it closely. Yet, this land is anything but silent. It is alive with movement, not a stillness frozen in time. The earth has always been restless, and during the age of Pangea, this restlessness is palpable. Powerful forces churn beneath the surface, invisible yet relentless. They push continents together, merging them into one colossal mass. Mountains rise from the crust, deep valleys form, and volcanoes erupt, painting the sky with fire and ash. In the heart of this immense land, life unfolds under conditions that may seem almost unimaginable to us today. Far from the soothing embrace of the ocean, the climate is unforgiving. Without seas to carry moisture inland, vast stretches of arid land exist where rain falls infrequently. Here, life adapts and perseveres, revealing the resilience of nature in a challenging world. Summers transform into sweltering heat, while winters deliver a biting chill. The seasons are intense, the air is dry, and the sky stretches endlessly, punctuated only by the distant outlines of mountains or the silhouettes of resilient forests. Yet, life thrives in every nook and cranny. Towering plants dominate parts of the landscape, while expansive red deserts roll toward the horizon. You might encounter creatures that are unrecognizable, strange reptiles bearing hints of early mammals, and insects that dwarf anything you would see today. The earth pulses with life, but it's a unique kind, molded by the extraordinary rules of this unified world. Perhaps the most striking aspect is the absence of boundaries. In our time, we know a planet divided by oceans, but during the age of Pangea, no such barriers existed. A river could originate in what we now call Asia and meander into what would eventually become Europe, uninterrupted by seas. Forests could extend across territories that would, in time, be separated into distinct continents. The same species of animals could roam freely from one end of the land to the other. How does this interconnectedness make you feel about the world we inhabit today? Imagine a time when Earth was a single vast landmass, connected in ways that are difficult to fathom today. This supercontinent, known as Pangea, was immense, yet it was never meant to last. The very forces that formed it were always at work, preparing to pull it apart. This is the essence of our planet. Continents drift, oceans shift, and mountains rise and fall. While Pangea existed, it left lasting imprints on our world, shaping the evolution of life and laying the groundwork for the landscapes we know today. Before we explore the moment when Pangea began to separate, let's take a step back and consider the forces that created it. To truly grasp what life was like on that ancient land, we must first understand how the Earth came together as one. This narrative begins not with a sudden event, but with a slow, steady movement. Beneath us, the Earth's crust is divided into massive plates that glide over the softer, hotter material below. This movement is gradual, measured in centimeters each year. Yet, over time, it transforms the entire planet. Long before Pangea, there existed other supercontinents, each with its own story. Ronia, Nuna, and others, names that often remain unspoken outside the realms of geology, once united and then separated, their fragments drifting apart. This movement set the stage for the emergence of Pangea. Over countless millions of years, smaller continents and island chains collided, merging into larger landmasses. Each collision sculpted mountains that reached toward the sky, formed extensive ranges of stone, and left deep scars in the Earth's crust. These ancient seams still linger today, concealed beneath our feet. As these pieces gradually fused together, the Earth eventually held one immense landmass. It's nearly unimaginable to comprehend the scale of this transformation. Picture yourself standing deep within Pangea, thousands of kilometers away from the nearest ocean. The air would feel different, and the climate would be harsher. You would lack that familiar sense of closeness to the coast, without the scent of salt carried on the breeze. This was a world of vast continental interiors, where the seasons could swing to extremes, and isolation was profound. Yet, this very isolation played a crucial role in shaping life. Insects grew larger, likely due to elevated oxygen levels in the atmosphere. Reptiles adapted to thrive in the dry heat of the interior. Meanwhile, in coastal areas, early forests formed green corridors, allowing life to spread. As you reflect on these ancient landscapes, consider the intricate tapestry of life that evolved in such isolation. What stories might these forgotten names tell? In this dynamic landscape of ever-changing climates and interwoven terrains, the ancestors of future creatures, dinosaurs, mammals, and even the earliest birds begin to take shape. The land itself tells a story of transformation. Volcanoes erupt, casting ash into the sky, which eventually settles into the soil. Rivers carve long valleys, transporting minerals from the rising mountains to the lowlands. Deserts expand and retreat with the seasons, creating a planet that is constantly in motion, yet unified by one colossal continent. If you look closely, the signs of this unity are etched in both stone and sky. The winds, too, must have felt different. In today's world, oceans alter and redirect global air currents. However, during the time of Pangea, the absence of those dividing seas allowed winds to sweep across vast distances with minimal interruption. Dust from the inland deserts could travel all the way to coastal edges, nourishing distant forests. Storms roamed further, unimpeded by ocean barriers. This singular arrangement of land profoundly influenced the planet's climate, creating a world where every sunrise illuminated a horizon defined by a seamlessly connected Earth. As you reflect on this ancient world, what feelings does it evoke in you? You find yourself contemplating a single vast world, all under the same sky. Before the continents united into one great landmass, Earth existed quite differently. Hundreds of millions of years before Pangea formed, the planet was a mosaic of smaller continents, each drifting slowly over a deep, ancient ocean. These land fragments never remained stationary for long, at least not in the grand scheme of geological time. They moved as they always do, driven by the slow, relentless motion of tectonic plates. Mountains emerged where these plates collided, and oceans opened as they separated. Each shift was not measured in days or years, but in millions of years. Yet every tiny movement brought the Earth closer to becoming a single, united world. To grasp this transformation, imagine the Earth during the late Paleozoic era, around 300 million years ago. By this time, several major continental blocks were already drifting across the globe. There was Laurentia, which would evolve into North America, and Gondwana, encompassing what would become South America, Africa, Antarctica, Australia, and India. Smaller pieces like Baltica and Siberia also played their part in this grand geological tale. As you reflect on these ancient movements, consider how they set the stage for the world we know today. Would you like to explore more about this fascinating journey? Imagine a world where land masses are on a gradual journey toward one another, destined to unite in a magnificent embrace. This journey began long before the well-known supercontinent Pangea. It traces back to Rodinia, which existed nearly a billion years ago. As Rodinia broke apart, it scattered land fragments into new configurations, only to later regroup into another supercontinent called Panatoia. However, this formation was short-lived. It too fractured, and its pieces began drifting once more toward each other. These cycles of assembly and separation are part of what geologists refer to as the supercontinent cycle, a natural rhythm of the Earth's crust shaped by the movement of tectonic plates. As these land fragments draw closer, the oceans that once separated them shrink. Take the Reek Ocean, for example. It once lay between Laurasia, an early combination of North America and parts of Europe, and Gondwana. Over millions of years, this ocean gradually narrowed until it vanished completely, swallowed by the merging continents. When land meets land, the collision is anything but gentle. Rocks crumple under immense pressure, much like paper. Entire mountain ranges rise, where two tectonic plates lock together. The Appalachian Mountains in North America and sections of the Atlas Mountains in Africa stand as enduring testaments to these ancient impacts. Isn't it fascinating to think about the forces that shape our planet? As you reflect on these connections, you may feel a sense of wonder about the Earth's dynamic nature. If you're intrigued, why not continue to explore these geological wonders together? Imagine the scars left by ancient collisions that brought Pangea into existence. From above, the world would appear quite unusual. You would witness massive land masses inching toward each other, surrounded by a vast ocean known as Panthalassa. As these continents converged, entire island chains disappeared, their volcanic peaks crushed between the colliding plates. Shallow seas vanished, and the boundaries between land masses blurred until they ultimately merged into one. During this slow-motion dance of collision, the climate was also transforming. Large ice sheets still clung to parts of Gondwana, particularly in areas that would one day become South America, Africa, and Antarctica. The rocks tell a story, marked with scratches from ancient glaciers, revealing that even while Pangea was forming, the Earth fluctuated between colder and warmer periods. As the continents collided and sealed off smaller seas, ocean currents shifted, and the atmosphere began to adopt a new rhythm. These climatic changes were not mere background details, they played a crucial role in shaping life on Earth. When continents collide, they create vast highlands and mountains, altering everything in their vicinity. They redirect winds and change weather patterns. As you reflect on this monumental transformation, consider how interconnected our planet's history is. Would you like to continue exploring these fascinating changes? Moisture clings to one side, while long rain shadows stretch across the other. In the era before Pangea fully formed, these shifting landscapes were already shaping the course of evolution, laying the groundwork for the plants and animals that would flourish when the supercontinent finally emerged. If you could transport yourself to this time, you would encounter landscapes that feel both familiar and foreign. Vast expanses of lowland swamps covered parts of what would eventually become North America and Europe. Towering forests of primitive trees stretched across the horizon, known as the Carboniferous forests. These dense, humid woodlands, filled with decaying plants, would eventually give rise to the coal seams we still mine today. The air was rich in oxygen, even more than what we breathe now, allowing some insects to grow to astonishing sizes. Imagine dragonflies with wings nearly a meter wide, gliding above the treetops, while giant millipede-like arthropods crawled along the forest floor. It was a world teeming with life, and Earth still exploring its potential. To the south, Gondwana told a different tale. Much of it lay closer to the polar regions, where glaciers carved intricate patterns across its surface. Imagine vast, frozen expanses, starkly different from the warm swamps near the equator. Yet they coexist, part of a planet undergoing a profound transformation. As continents gradually drift toward one another, climate zones shift, pulling cold regions north and pushing warm areas south. This blending creates a new global order. Over millions of years, the last significant collisions occur. Large landmasses like Russia collide with Gondwana, causing mountain ranges to rise dramatically. The smaller tectonic plates that once floated in between are caught and crushed. This marks the true beginning of Pangea. It is not merely a single event. Rather, it is a series of impacts and merges, each one bringing the planet closer to a colossal continent that will define an entire geological age. By the end of this process, the map of Earth appears remarkably simple. Almost all the land merges into one vast expanse. Surrounding it, Panthalassa stretches endlessly in every direction, a single ocean that reaches the horizon no matter where you stand. Along one edge of Pangea, an inland sea known as the Paleotethys remains, a lingering remnant of ancient oceans that have not yet fully closed. As you reflect on this transformation, consider the immense forces at play and the interconnectedness of our planet's history. Each shift, each collision, shapes the world we know today. Would you like to explore this journey further? Imagine a world where the continents have finally come together, forming a single massive landmass. This is the moment when Pangea emerges, a time when the Earth is transformed in ways that go beyond mere geography. The last great collisions have concluded, leaving towering mountains and expansive deserts in their wake. The climate begins to shift, setting the stage for life that will thrive for millions of years. Yet, this is just the beginning of Pangea's story. With the continents locked in place, the planet is poised for dramatic changes. No longer an idea in motion, Pangea stands as a tangible reality. The long journeys of land masses, once separated by vast distances, have culminated in the formation of a unified continent, encircled by a vast ocean. This new Earth is devoid of the familiar divisions we recognize today. The sheer scale of this transformation reshapes every aspect of the planet's surface. The creation of Pangea isn't merely about merging continents, it signifies a profound shift in the entire Earth system. Mountain ranges rise where land has buckled under the pressure of these monumental collisions, marking the dawn of a new era. As you contemplate this remarkable chapter in Earth's history, consider how these changes set the stage for the rich tapestry of life that will unfold in the ages to come. Would you like to explore further into this fascinating journey? You observe deep scars etched into the Earth's crust, serving as sutures that bind the fragments into a cohesive whole. These scars remain visible today as geologists trace their paths across continents, once joined but now separated by vast oceans. They reveal the violent collision zones where tectonic plates crash together, folding and fracturing the crust. As rock grinds against rock, heat builds, and magma pushes its way upward, giving rise to chains of volcanoes that can stretch for thousands of kilometers. During the birth of Pangea, this relentless process shaped the central regions of the supercontinent. Towering mountains emerged, rivaling the scale of today's Himalayas. Though these majestic ranges would eventually erode, their peaks once symbolized the raw power of our planet's restless crust. In the midst of this upheaval, vast basins opened between the mountains. Rainwater and runoff from the newly formed highlands carved extensive river systems that crisscrossed the supercontinent's interior. These rivers nourished wetlands and deltas, transforming them into some of the most fertile regions of their time. Fossils preserved in these ancient basins narrate the story of lush ecosystems that thrived beneath the towering shadows of the newly formed highlands. As you reflect on this incredible journey of our planet, consider the interconnectedness of these geological processes and the life they nurtured. Would you like to explore more about the wonders of Earth's history? The formation of Pangea introduces a new kind of land, one that the Earth has never experienced on such a grand scale. As the continents merge, the heart of this immense landmass becomes increasingly isolated from the calming influence of the sea. This isolation creates a continental core so distant from the ocean that moisture from coastal areas rarely reaches it. Consequently, vast deserts emerge, some potentially stretching thousands of kilometers. In the center of this supercontinent lies a realm of extremes. Scorching summers and frigid winters dominate the landscape, while the edges of Pangea, closer to the surrounding ocean, enjoy a milder and wetter climate. This stark contrast between dry interiors and lush coasts becomes one of Pangea's defining characteristics. Even today, we can trace this climatic pattern in the geological record. Scattered across the ancient continents are red beds, layers of iron-rich sediment that formed under hot, arid conditions. These rocks serve as the remnants of the deserts that once sprawled across Pangea's core. In contrast, coal deposits found in swampy, humid regions reveal that dense forests thrived near the coasts, nourished by heavy rains drawn inland from the sea. The climate of Pangea is not only a product of its immense size, but also of its unique geographical position. As you reflect on this, consider how the interplay of land and sea shapes environments, both past and present. Would you like to continue exploring these fascinating transformations? Imagine a time when the supercontinent, Pangea, flourished. Much of it lies along the equator, creating vast tropical zones that fill its center. These regions experience intense heat and seasonal monsoons, while the southern and northern edges stretch into polar climates. This unique arrangement of land has never been seen before in Earth's history, offering an extraordinary range of climates, all on one massive continent. From the frozen expanses of the south to the lush rainforests near the equator, life flourishes across this continuous land. In the warm, humid coastal areas, dense forests of towering conifer-like trees and seed ferns thrive. Their roots anchor the soil, while their expansive canopies trap moisture in the air. These vibrant forests provide a haven for early reptiles, amphibians, and an astonishing variety of invertebrates, including insects of remarkable size. In contrast, the arid interior tells a different story. Here, plants develop ingenious ways to conserve water, and animals adapt to endure the long stretches of heat and scarcity. It is a world where survival hinges on every adaptation, each one a response to the demands of a vast and unforgiving landscape. The formation of Pangea also transforms the oceans, as nearly all land gathers in one place, reshaping the world around it. What do you imagine life was like in such a dynamic environment? You find yourself immersed in a world shaped by the vast Pantalassa, the ocean that dominates the globe. Its currents wrap around the supercontinent of Pangea, redistributing heat and influencing climates everywhere. Along the edge of this landmass, the Paleoteous Sea clings to existence. It stands as a remnant of ancient oceans, serving as a crucial pathway for marine life. Here, sheltered waters foster thriving reefs and ecosystems, even as the open ocean stretches endlessly. The unique arrangement of land and sea generates powerful wind systems. Without the modern continents to disrupt their flow, global wind patterns become more direct and intense. Seasonal monsoons sweep across Pangea, bringing heavy rains to some areas, while leaving others parched and dry. Dust from interior deserts travels vast distances, carried by winds for thousands of kilometers, eventually settling in coastal forests or sinking into the ocean. Yet, perhaps the most profound impact of Pangea's formation is its role in shaping the future of life itself. By bringing all continents together, Pangea eliminates the barriers that once kept ecosystems apart. Species that had evolved in isolation suddenly find themselves in contact with one another, setting the stage for a new chapter in the story of life on Earth. Predators venture into new territories, following their prey. Plants and animals expand into regions they could never have reached before. This mingling of life shapes evolutionary paths for millions of years. Fossils discovered today in distant places like South America, Africa, and India often appear nearly identical. This serves as evidence that during the age of Pangea, the same species roamed across lands now separated by vast oceans. Even as Pangea stabilizes, it is never truly at rest. Deep within the Earth, the same forces that formed it continue to shift. Heat builds beneath the crust, gradually weakening it in certain areas. Faults emerge, initially invisible, but these fractures will one day mark the beginning of the great breakup that will scatter the continents once more. For now, however, Pangea remains intact, an extraordinary arrangement that dominates the Earth's surface and defines an entire age. To walk across it in that time would allow you to experience the planet in a way that is impossible today. There are no distant coastlines hidden beyond the horizon, no foreign continents waiting across an ocean. There is only one world, vast and interconnected, bound by the same sky, the same winds, and the same restless heartbeat of the earth beneath. In this unified world, a remarkable new chapter in the story of life begins. The earth, once divided by vast oceans, now exists as one colossal landmass. Imagine a time when there are no seas separating regions, no isolated continents hidden behind miles of open water. Instead, envision Pangea, a seamless expanse stretching from one horizon to the next. Picture yourself standing at the heart of this immense continent. You could wander in any direction for months, and the ocean would never greet you on the horizon. Instead, you would traverse expansive plains where the sky appears even more vast than it does today. As you journey, you would encounter rivers meandering across entire landscapes, weaving through territories that know no boundaries. As you explore, you would transition from one climate to another, not because you crossed an ocean, but because this land is so immense that the weather changes gradually over unimaginable distances. This world is not defined by isolated ecosystems. In our current reality, oceans create natural barriers that separate species, leading to the development of distinct forms of life on each continent. Take a moment to reflect on this extraordinary vision of interconnectedness, where life flourishes across a unified landscape. What might it be like to experience such a world? On Pangea, there were no barriers. Plants and animals roamed freely, crossing vast expanses of land without the interruption of oceans. Fossils tell this story. Identical species have been discovered on continents now separated by thousands of kilometers of water. Reptiles that once thrived in what is now South America also left their remains in Africa. Early plant species spread across regions that today are scattered around the globe. Pangea allowed life to flourish, as if the entire world were one interconnected habitat. The absence of borders also transformed the land itself. Winds could travel further, unimpeded by mountain ranges or broken coastlines. Massive air currents swept across Pangea, carrying heat and dust from the arid interior to the coasts. However, rainfall found it difficult to penetrate the heart of the continent. Moisture from the surrounding oceans would fall as rain along the edges of Pangea, nurturing dense forests and wetlands. Yet, by the time the air reached the deep interior, it had little moisture left to offer. What remained were vast, arid zones, deserts so expansive they stretched even farther than today's Sahara. This created a striking contrast with the humid belts near the coast, making Pangea a world of extremes. As you reflect on this ancient land, consider the incredible diversity of life that once thrived there. The interplay of climate and geography shaped an environment unlike any other. Feel the wonder of a time when the world was a single, connected habitat, and let your imagination roam across its vast landscapes. The rivers that flow through the supercontinent are more than mere waterways. They serve as vital pathways for life. Early amphibians navigate these currents, moving from one region to another, guided by the refreshing streams. Along the riverbanks, ancient forests of conifers and seed ferns create lush green corridors, linking various parts of Pangea. Some rivers are so extensive that in our time, their courses would traverse multiple continents. Yet in the realm of Pangea, they form part of an expansive, unified landscape. Mountains rise dramatically, remnants of the powerful collisions that shaped Pangea. These colossal ranges emerge where continents once collided, their crumpled layers stretching skyward. Some of these mountains are so vast that they connect the land like seams in a fabric. Over time, erosion has softened their peaks, while rivers carry sediments into the surrounding lands, enriching the soil and nurturing sprawling floodplains. Traveling across this supercontinent offers a gradual journey through diverse environments. You would transition from humid coastal forests into open savannas and grasslands. As you continue, the landscape shifts again, leading you into seemingly endless deserts, where the red sands are only interrupted by rocky outcrops and the occasional winding river. As you journey farther, you might discover lush forests nourished by mountain rains, which create unique microclimates within the vast expanse. Pangea, though unified, is anything but monotonous. Its immense size allows for a diverse range of landscapes to coexist, all woven together into one grand landmass. Without borders to restrict them, animals could roam freely. Early reptiles, the ancestors of future dominant species, traversed great distances across Pangea without the barrier of oceans. They spread across this immense territory, adapting to its varied environments. Some found refuge in the humid coastal forests, while others thrived in the arid interior. This remarkable mobility enabled species to expand rapidly, forming ecosystems that stretched across much of the supercontinent. Even the sky must have felt different in this ancient world. Today, coastlines disrupt the flow of wind and shape regional weather patterns. But on Pangea, the vast land allowed weather systems to move uninterrupted for thousands of kilometers. Storms forming near the coasts could surge deep into the continent, their rain gradually fading into dry winds. Monsoons could reach astonishing proportions, bringing heavy rains to one side while leaving the other parched and dry. Isn't it fascinating to ponder how life thrived in such a dynamic environment? Pangea is not just a vast, silent expanse. It is alive with vitality. Primitive forests blanket entire regions, while coastal swamps buzz with amphibians and early reptiles. In the arid heart of the continent, resilient plants cling to the soil, braving the relentless winds. Smaller creatures flit between patches of shade, proving that life endures even in the harshest conditions. Imagine standing in this immense landscape. The horizon stretches endlessly, leaving you with a sense of wonder and perhaps a bit of overwhelm. There is no ocean to provide a familiar boundary. Instead, everything expands outward in every direction, making the world feel larger than life itself. This sense of scale defines existence on Pangea. Travel unfolds slowly, movement spans great distances, and even the sky seems to echo the vastness of the land below. In this world, everything is interconnected. Mountains, deserts, forests, and rivers form a single continuous earth. It is this unity that empowers Pangea, shaping the winds and rains, guiding the distribution of plants and animals, and setting the stage for the remarkable transformations that will follow in the history of our planet. Imagine a vast, borderless land, a place where evolution unfolds, and every living creature faces new challenges. This is Pangea, a singular continent that, despite its unity, showcases incredible diversity. Its edges and interior feel like entirely different worlds. Along the coastlines, the nearby ocean exerts a powerful influence. The humid winds from Panthalassa sweep inland, nurturing lush forests and vibrant swamps where life flourishes in abundance. However, as you venture further from these coastal havens, that oceanic embrace begins to wane. The green landscapes gradually give way to open plains, eventually leading to the stark, arid expanses of Pangea's vast interior deserts. The coasts are alive with movement and vitality. Warm, shallow seas kiss the land, creating wide tidal flats where the lines between land and water blur. Here, amphibians linger by rivers and wetlands, while early reptiles stalk through towering forests of conifers and seed ferns. Insects, some astonishingly larger than their modern counterparts, buzz through the humid air, thriving in the warm, wet climate regulated by the ocean's presence. These coastal ecosystems flourish, reminiscent of the tropical belts we see in our world today. As you reflect on this ancient landscape, consider the intricate balance of life that exists within it. What stories might these environments tell if they could speak? Fossils discovered in coastal areas reveal a lush landscape filled with diverse species. Imagine a setting reminiscent of today's mangrove swamps, where twisting roots and slow-moving waters are home to early fish and invertebrates. As you venture farther inland, still close to the ocean's moisture, expansive river systems carve through the land. These rivers nourish broad floodplains where dense forests thrive, creating the most hospitable regions of Pangea. Here, food and shelter abound, and the seasonal rhythms are predictable and steady. Yet, as you move away from the coasts, the environment shifts dramatically. In the deep interior of Pangea, rainfall becomes scarce. The immense size of this landmass, which connects nearly all of Earth's surface, also shapes its most defining feature, a continental heartland so distant from the sea that it transforms into a vast desert, unmatched by any modern landscape. These deserts are not mere patches of sand. They stretch endlessly, broken only by occasional rocky uplands or solitary rivers. Geologists have unearthed evidence of these arid regions in the form of red beds, layers of iron-stained rock that formed under scorching, dry conditions. Isn't it fascinating to consider how this ancient world contrasts with our own? These rocks reveal that much of Pangea's interior was a landscape dominated by relentless sun and scarce rainfall, where only the hardiest forms of life could endure. During the day, the air hung heavy and heat shimmered off the ground in waves. As night fell, the absence of clouds or nearby oceans led to a sharp drop in temperature, leaving the land cold beneath a canopy of brilliant stars. It was a realm of extremes, where survival demanded remarkable resilience. In this harsh environment, plants were few and tough, with deep roots and hardened leaves that resisted water loss. Small reptiles and early mammal-like creatures adapted by burrowing for shelter or becoming active during the cooler hours to escape the punishing sun. Between the arid deserts and coastal forests lay transitional zones, regions of grasslands and open woodlands, where the climate shifted gradually from wet to dry. These belts may have served as vital highways of life across Pangea, allowing animals and plants to move between different parts of the continent. Along these routes, species spread across the supercontinent, leaving behind the widespread fossil patterns that scientists uncover today on continents now separated by oceans. Isn't it fascinating to think about the resilience of life in such extreme conditions? As we explore these ancient landscapes, let's take a moment to appreciate the journey of life that has shaped our world. As you explore the varied coasts of Pangea, you'll notice they are anything but uniform. Some areas experience consistent rainfall, nurturing lush, swampy forests, while others, tucked away in the rain shadows of towering mountains, remain surprisingly dry for their latitude. Monsoonal winds, influenced by the vastness of Pangea and the sun's seasonal journey, create a rhythm of floods and droughts in certain coastal zones. The land is in constant motion. Each year, storms push inland, rivers swell and recede, and forests adapt to the cycles that have persisted for millions of years. This striking contrast between coastal regions and the interior has shaped not just the scenery, but also the behavior of the animals that inhabit these areas. Coastal zones brim with food, supporting a diverse array of species, while the deserts present a harsh environment where competition is intense and life is highly specialized. Fossil records reveal creatures in these arid landscapes, showcasing unique adaptations like burrowing habits and specialized teeth designed to thrive on tough, dry vegetation. Life across Pangea may not be evenly distributed, but it is deeply interconnected. Rivers carve their paths from mountains to coasts. Winds carry dust from deserts to forests, and migration routes weave through these diverse habitats, linking them in a delicate balance. As you reflect on these connections, consider how each element plays a role in the grand tapestry of life on Pangea. Would you like to continue this journey, or take a moment to ponder these thoughts? Imagine the air around you, infused with a sense of interconnectedness. Dust storms from the arid interior deserts travel great distances, scattering minerals across the vast expanse of Pangea and into the surrounding oceans. This constant flow of materials creates a bridge between land and sea, nurturing the intricate cycles of nutrients that sustain diverse ecosystems on both fronts. As you traverse Pangea, you encounter striking contrasts. The lush, vibrant forests along the coasts give way to the stark, sun-baked deserts, and then back to the embrace of another distant sea. It is a singular world, yet within its boundaries lie climates and landscapes that today would be divided by oceans. This is the true essence of Pangea, a land so immense that it harbors its own extremes. However, this supercontinent is not a finished masterpiece. The mountains shift and reshape, the climate evolves, and the deserts expand and recede. Coastal regions transform with the ebb and flow of ancient seas. Pangea is a world alive with motion, ever-changing and dynamic. As you venture deeper into the heart of Pangea, you leave the ocean's influence behind. The moisture that nourishes the coasts fades away, revealing a landscape shaped by its own unique forces. The winds have lost their strength, and the air grows dry beneath an endless sky. You find yourself in the great interior, a land characterized not by what it possesses, but by what it lacks. Here, rain is a rare visitor. Months can slip by without a single storm, and when the clouds do finally gather, their showers vanish almost as quickly as they arrive, absorbed by the thirsty ground. This interior stretches vast, reaching for thousands of kilometers in every direction. While modern deserts like the Sahara or the Gobi might seem immense, they pale in comparison to the arid expanses that dominate the center of Pangea. Geologists studying ancient rocks uncover layer after layer of red sandstone, stained with iron and baked by relentless heat. These layers stand as evidence of an arid world that has existed for millions of years. You can see how this landscape has been sculpted by sun and wind, where rivers are scarce and lakes are fleeting, disappearing when the brief rains fade away. The climate here is harsh and unyielding. During the day, the sun beats down without mercy. With no clouds to soften its glare, the ground heats up, causing the air to shimmer with waves of rising heat. As night falls, the temperature drops sharply. Without moisture to retain the warmth, the land cools quickly, leaving the air cold and thin beneath a vast dome of stars. Take a moment to reflect on this stark beauty. What thoughts does it inspire in you? Life in this environment must adapt to its rules or risk disappearing completely. Here, vegetation is sparse yet resilient. Hardy plants cling to the soil, including early conifers and seed ferns, all designed to withstand the ongoing struggle for water. Their roots dig deep, seeking moisture hidden far beneath the surface. Between these scattered pockets of green lie vast plains of dry earth and rock, occasionally interrupted by shifting dunes and faint traces of ancient riverbeds. These rivers, when they flow, often do so briefly, only to vanish into the ground or evaporate under the unyielding sun. The animals that inhabit this land show similar signs of adaptation. Many are small, built to conserve water. Some burrow deep underground, escaping the heat of the day and emerging only as the sun begins to set. Others navigate the edges of the remaining rivers, relying on the scarce water and vegetation they can find. In this rugged landscape, tracks of early mammal-like reptiles mingle with the footprints of smaller predators and the occasional larger herbivore, all following seasonal shifts in search of better grazing grounds. What stories do these tracks tell of survival and resilience? As you reflect on this, consider the delicate balance of life in such a challenging environment. The wind is a constant companion in the vast interior. With no forests to hold it back, it sweeps across the open land, carrying dust from one horizon to the next. Over millions of years, this dust has left its mark, settling in layers that remain locked within the rock record. Imagine a world filled with muted colors, reds and browns baked by the sun, pale skies shifting from dazzling blue to a deep, star-strewn black. The only interruptions to this monotony are the jagged outlines of distant mountains. Yet, despite this harshness, life persists. Even in the dry heart of Pangea, ecosystems thrive. Small oases emerge where underground springs surface. Seasonal floods from distant mountains carve temporary rivers through the parched land, drawing life from every direction. Fossils from these areas reveal sudden bursts of activity, showing that for brief moments, these arid regions come alive when water returns, only to fall silent again as the heat reclaims them. The vastness of the interior presents another challenge: isolation for the animals and plants that call the heart of Pangea home. The distances are staggering, and migration from one fertile region to another can take generations. Can you imagine the journey? As you explore the vast interior of Pangea, you notice how populations have adapted, becoming specialized to meet the challenges of a dry environment. Over time, these species evolve, transforming into forms that bear little resemblance to their coastal relatives. This gradual adaptation serves as a powerful engine of evolution, allowing life to flourish in conditions that few can endure. The wind-driven climate plays a significant role in reshaping the landscape. Without heavy rainfall, erosion is a slow process. Rocky outcrops, remnants from Pangea's formation, stand exposed for millions of years. Their surfaces bear the marks of time, scoured yet intact, while sand carried by relentless gusts sculpts dunes and carves intricate patterns into stone. These ancient weathered signs remain preserved in the rocks we study today, silent witnesses to a world where the desert seems endless. Despite its harshness, this great interior is intricately connected to the rest of Pangea. Dust from these arid lands drifts outward, carried by the wind to the wetter coastal regions, enriching distant forests with essential minerals. Occasionally, seasonal storms form at the edges of the interior, sweeping outward and pushing dry air into greener lands. These shifts in weather patterns extend far beyond the desert, illustrating how this seemingly empty expanse influences the entire supercontinent. In its own unique way, the interior is linked to the fate of its coasts, a reminder of the interconnectedness of this ancient world. Imagine traveling through the heart of Pangea. Here silence envelops you, a profound stillness that feels almost alien today. There are no waves crashing, no leaves rustling in the breeze. Instead, you hear only the gentle sweep of air across the stone and the occasional call of an animal, uniquely adapted to this vast emptiness. But this silence carries a weight of meaning. In this arid core, life learns to endure, preparing itself for the trials that the evolving world will soon present. While the center of Pangea is marked by dry winds and expansive horizons, its edges tell a different story, shaped by the surrounding ocean. Panthalassa, the immense global sea, stretches out in every direction, so vast that it seems to go on forever, even from the shores of Pangea. This ocean is not just a backdrop, it plays a crucial role in influencing the climate, ecosystems, and the movement of life across the planet. Where land meets sea, transformation occurs. The moisture carried inland by ocean winds nourishes the coastal regions, creating lush belts of life that stand in stark contrast to the barren interior. Here, rivers swell with seasonal rains, wetlands teem with primitive amphibians, and forests rise so densely that they form nearly unbroken canopies in some areas. As you reflect on this dynamic interplay between land and sea, consider how life adapts and thrives in these diverse environments. Would you like to continue exploring this fascinating world, or take a moment to pause and absorb what you've just learned? Along these coasts, life flourishes, sustained by the dynamic relationship between land and water. The ocean, known as Panthalassa, is remarkable in its vastness, covering nearly 3/4 of our planet. Its deep currents flow slowly, yet reach far and wide. With only one enormous continent, Pangea, to interrupt its flow, the waters move in expansive loops, transporting warmth from the equator to the poles. This consistent movement plays a crucial role in regulating the coastal climate, while the interior lands experience more extreme conditions. Near the shorelines, Panthalassa's impact is both immediate and striking. Warm, shallow seas inundate low-lying areas along the continental edges. These shallow zones, sometimes extending for hundreds of kilometers, create ideal habitats for life. Ancient reefs, formed by early corals and sponges, rise from the ocean floor. Schools of primitive fish glide through the clear waters, while trilobites, nearing the end of their era, still cling to existence in isolated pockets. In these coastal waters, nutrient cycles weave a connection between land and sea. Rivers flow from the interior, carrying mineral-rich sediments that nourish the shallow marine ecosystems. These nutrients spark blooms of plankton, which in turn support a diverse web of marine life. As you reflect on this intricate balance, consider the beauty of these ecosystems and the life they sustain. Fossils from ancient seabeds reveal a tale of abundance. You can almost imagine the diverse fish, the invertebrates adorned with intricate shells, and the fierce predators that roamed the waters long before dinosaurs took their first steps on land. The coasts, shaped by the ocean's moods, tell another part of this story. Seasonal monsoons, driven by the vastness of Pangea, brought powerful storms crashing against the shore. These rains replenished rivers and wetlands, but they also caused flooding, reshaping the landscape year after year. In some areas, these storms might have carried salty air inland, leaving behind crusted flats where water evaporated quicker than it could accumulate. Each cycle etched another mark into the land, creating a coastline that was in constant flux. Despite the harshness of its interior, Pangea's coasts served as vital connections. They bridged the land and the ocean, acting as gateways for life to flow between these two worlds. Amphibians ventured into the wetlands to lay their eggs, relying on the steady flow of fresh water. Reptiles soon followed, evolving traits that freed them from the need for aquatic breeding, allowing them to explore further inland. Even the earliest ancestors of mammals likely emerged near these coasts, their survival intricately linked to the rich ecosystems that thrived between the sea and the land. Imagine a world where the air is alive with activity. Insects buzz through lush forests that hug tidal flats. Early reptiles bask on sun-warmed rocks beside shallow lagoons, while primitive ferns and seed plants thrive in the humid climate. Their roots dig deep into nutrient-rich soil, washed down from distant islands. Every inch of the coast is vibrant and teeming with life, where each season brings fresh growth, migrations, and the struggles of survival. Yet the ocean, while a source of life, also draws clear boundaries. Just a few hundred kilometers inland, the greenery starts to fade. Rainfall becomes scarce, and the air grows drier. The ocean's influence is powerful, but it has its limits. The stark contrast between the fertile coastal areas and the arid interior is one of Pangea's defining characteristics. It serves as a poignant reminder that even in a world of interconnected land, the edges and the center follow very different rules. The ocean itself, often perceived as constant, is anything but still. Its tides and currents continuously reshape the coastline of Pangea, eroding cliffs and depositing sediments in new locations. Some regions have been submerged under shallow seas for millions of years, only to be revealed again when the waters recede. What stories do you think these landscapes hold? As you reflect on this dynamic world, consider the delicate balance of life that thrives along its edges. As the Earth's crust shifts, some regions rise, revealing once submerged seafloors to the air. This ongoing dance between land and sea creates a constantly evolving landscape, prompting life to adapt time and again. Panthalassa, the great ocean, is not alone in this transformation. Along the eastern edge of Pangea lies the Paleoteeth Sea, a smaller yet equally vital body of water. In this relatively sheltered sea, many early marine species discover stable habitats. The shallow waters, protected by extensive continental shelves, become cradles of evolution, nurturing a diverse array of creatures that will eventually spread to the vastness of the ocean. This sea stands in contrast to the deep, open expanse of Panthalassa, offering a quiet refuge while the rest of the planet's waters churn in their boundless movements. Imagine yourself on Pangea's coastline. You would see no distant islands or neighboring continents rising from the waves, just the infinite ocean stretching toward the horizon, an endless blue void surrounding the singular landmass of Earth. The rhythmic sound of waves crashing against the shore, the distant cries of primitive reptiles from nearby forests, and the steady winds sweeping inland serve as reminders of a world that is vast, unbroken, and ever in motion. The oceans at the edge of everything are not merely boundaries. They serve as the living, breathing skin of our planet, weaving together water, air, and land into a harmonious system that sets the rhythm for life on Earth. From these coasts, the narrative of Pangea unfolds, reaching inward to the forests and plains that lie between the sea and the desert. Here, the planet's unique and evolving life takes its next steps. The air of Pangea is unlike the air we know today. At times, it is thick, at others, it is thin. Its very composition leaves an imprint on the creatures and plants that inhabit this world. To step outside and breathe during this ancient era would mean inhaling an atmosphere shaped by a planet in transition, carrying the weight of its geological history, while holding the promise of what is yet to come. Evidence locked within rock layers reveals that oxygen levels during certain periods of Pangea's existence were higher than what we breathe now. In the late Carboniferous period, just before Pangea reached its full form, oxygen may have constituted as much as 30% of the atmosphere, compared to the 21% we experience today. This extra oxygen transformed everything, fueling the growth of enormous insects and arthropods. Imagine the vibrant life that thrived in such an environment. What might it have felt like to exist in a world where the air was richer, where life flourished in ways we can scarcely comprehend? As we reflect on this ancient time, we are reminded of the intricate connections that bind us to our planet's past and future. Would you like to continue exploring this fascinating journey, or perhaps take a moment to pause and reflect? Imagine a world where creatures rely on simple diffusion to breathe. Picture dragonflies, their wingspans stretching longer than a human arm, gracefully soaring above dense forests. Envision millipede-like invertebrates growing to astonishing lengths, a sight that would astonish anyone today. In this environment, the air supports their growth, allowing them to become giants. However, this atmosphere is not static. As Pangea stabilizes and enters the Permian period, oxygen levels begin to dwindle. By the middle of this era, those levels might drop to around 15%. For modern humans, breathing in such conditions would be a challenge, but the animals of that time are uniquely adapted. Their lungs and circulatory systems evolved to extract every bit of oxygen they can from the thinning air. This shift transforms ecosystems, favoring species that can endure lower oxygen levels. Gradually, the oversized insects of earlier ages start to decline. Carbon dioxide also plays a significant role, and volcanic eruptions along Pangea's fault lines release vast amounts of this gas into the atmosphere, warming the planet and creating powerful weather systems. This greenhouse effect helps maintain the humidity and lushness of coastal forests, while the great interior grows increasingly arid. Can you feel the tension between life and the changing environment? It's a delicate balance, one that shapes the world in profound ways. The very chemistry of the air intertwines with the geology of the supercontinent. Each eruption and tectonic shift influences life in ways that echo through the bones of the surviving animals. For plants, this atmosphere presents both challenges and opportunities. Elevated levels of carbon dioxide promote the growth of vast forests. Seed ferns, towering conifers, and other ancient flora flourish, their leaves absorbing the gas and releasing oxygen in return. These forests transform into immense oxygen factories, nourishing the planet's atmosphere and stabilizing the climate. As they spread along river valleys and coastal lands, they create pockets of breathable abundance in a world otherwise marked by extremes. Yet the connection between air and life goes even deeper. The atmospheric circulation around Pangea is unlike anything we experience today. With nearly all the landmass gathered into one, wind patterns become larger and simpler, flowing unimpeded across thousands of kilometers. Warm air rises above the equator, driving powerful monsoons along the coasts, while cooler, dry air descends into the interior, nurturing the deserts sprawling across Pangea's center. The atmosphere itself acts as an engine, with every living thing existing within its currents. As you reflect on this intricate relationship, consider how the very air we breathe is shaped by these ancient processes. What might this tell us about our own connection to the world around us? Imagine standing beneath a sky that seems to shift in color, subtly transformed by the presence of volcanic aerosols during intense eruptions. Fine particles fill the air, scattering sunlight and casting a unique tint across the horizon. Picture sunsets ablaze in deep reds, their warm glow stretching across the flat, open lands of the interior. On clear days, the sky opens up, revealing an unbroken expanse of blue, vast and sharp, softened only by a hint of moisture. The breath of Pangea carries with it not just colors, but also heat. Without the moderating influence of smaller continents and oceans, the temperature swings are more pronounced. Summers in the interior are intense, baking under hot, dry air. Winters, in contrast, bring a sharp chill, the air thin and biting. Along the coasts, the climate is gentler, tempered by soothing ocean breezes. Yet, even in these milder regions, the rhythms of the supercontinent echo through the atmosphere. As the monsoon season arrives, humid winds sweep ashore, nourishing the forests with warm, moisture-laden air. When those winds shift, dry air reclaims the land, altering the landscape once more. In this dynamic environment, animals adapt, evolving efficient lungs to draw oxygen from a thinning sky. How do you imagine life thrives in such a world? You notice how some beings become masters of stillness, conserving energy, heat, and dryness. Plants adapt their leaf structures, skillfully opening and closing their pores to preserve water, while still absorbing the essential gases needed for growth. Each adaptation responds to the air around them, and every shift in the atmosphere sends ripples throughout the web of life. What stands out most about Pangea's air is not just its chemical composition, but its vast reach. A single atmosphere envelops every corner of this supercontinent. Winds originating from the arid interior sweep toward the coasts, carrying dust and minerals that settle into distant soils. Moisture from the oceans drifts inland, gradually fading until it falls as rain. This air connects deserts to forests, mountains to plains, and every living entity to one another. Imagine standing on Pangea, breathing in the essence of that entire world at once. You inhale the dry heat of the interior, the salt-tinged winds from the coast, and the subtle traces of volcanic gases carried from far-off eruptions. Each breath serves as a reminder that on this single continent, air is not divided or contained. It is the common thread linking one end of the world to the other. As the atmosphere shapes life, life reciprocates by influencing the atmosphere, creating a feedback loop that defines this era and prepares the planet for the changes yet to come. Would you like to explore this intricate relationship further? In the air of Pangea, laden with history and vibrant with change, the beginnings of everything that would come are nestled. This world is on the brink of transformation, as its deserts, coasts, and forests have already set the stage. Life is starting to respond to the shifting environment. This is a time before dinosaurs, an era when the ancestors of future giants are taking their initial steps. The Earth has not yet been dominated by the towering creatures that will eventually reign, but the groundwork for their future is being laid quietly, one adaptation at a time. As the late Carboniferous transitions into the Permian, land life begins to specialize. The coastal forests are dense and humid, filled with competition. Here, amphibians thrive in rivers and swamps, their existence intricately linked to water. Yet, among them, new arrivals emerge: reptiles. These creatures possess a groundbreaking advantage: the amniotic egg. Unlike amphibians, reptiles are no longer bound to the water for reproduction. Their eggs, shielded by shells and membranes, can endure the dry land. This remarkable adaptation opens up the vast interior of Pangea, allowing access to deserts and arid plains that amphibians cannot inhabit. As you reflect on this pivotal moment in history, consider how these changes set the stage for the incredible diversity of life that would follow. Isn't it fascinating to think about the intricate web of adaptations that shapes our world? You are invited to continue exploring this journey through time, or perhaps take a moment to rest and ponder the wonders of evolution. In this time, Early reptiles are not the enormous predators or towering herbivores we might envision from later eras. Instead, many are small, nimble, and close to the ground, feeding on insects and other tiny creatures. Yet, a few begin to grow larger. Among these are the synapsids, a group that will eventually lead to the evolution of mammals. During this period, they stand as the dominant land animals, showcasing forms that are as varied as they are peculiar. Some, like Dimetrodon, possess impressive sails on their backs. These sails may serve to regulate their body temperature or perhaps for display purposes. Others have powerful jaws and robust bodies designed for endurance, roaming the arid landscapes of the supercontinent in search of prey. Meanwhile, in the forests and along the riverbanks, herbivorous synapsids graze on ferns and seed plants, their teeth adapted for grinding tough vegetation. Though they may be stocky and slow-moving, their size grants them a form of protection. In a world filled with vast landscapes and harsh climates, being large becomes an advantage. It allows them to travel further in search of food, endure longer periods without water, and adapt to the fluctuating seasons of Pangea. The insects of this age are remarkable in their own right, with oxygen levels higher during the earlier periods of Pangea's history. Some insects reach sizes that seem almost unimaginable today. As you reflect on this fascinating world, consider how life adapts and thrives in even the most challenging environments. Would you like to continue exploring this journey through time? Imagine a world where dragonflies, their wings stretching nearly a meter across, glide gracefully over the rivers. Picture millipede-like arthropods, several feet long, crawling across the forest floor. Although their reign is starting to wane as oxygen levels dip, they still dominate the landscape, serving as reminders of an era when the air nourished life to extraordinary sizes. Now, turn your thoughts to the ocean that surrounds Pangea, where life is equally vibrant. Here, large predatory fish, armored with thick scales, hunt through the open waters. In the shallows, sleek and efficient early sharks patrol their territory, their lineage already well established along the coasts and in the smaller inland seas. The seafloor teems with invertebrates like brachiopods, ammonites, and crinoids, diligently filtering nutrients carried by the currents of Panthalassa. These vast and deep oceans are intricately connected to the rhythms of the land. Dust from Pangea's deserts carries essential nutrients into the sea, while floods from coastal rivers replenish the shelves with minerals vital for sustaining marine ecosystems. As we explore the land, we begin to witness the first grand experiments in size. Among the synapsids and reptiles, forms are emerging that hint at what the future holds. What might these changes lead to? What wonders and challenges lie ahead? As you explore the ancient landscapes of Pangea, you notice the creatures that once roamed its vast expanses. Some of them grew heavier and more imposing, pushing the limits of what the land could support. Their fossilized remains reveal sturdy limbs, crafted to bear significant weight, and teeth designed for a diverse diet. While they are not yet the giants of the later Triassic and Jurassic periods, they stand as the precursors, evolution's early attempts to populate these colossal spaces with equally magnificent beings. The climate of this supercontinent plays a vital role in their development. In the lush coastal regions, food is abundant, with forests teeming with layers of vegetation. Here, herbivores can graze almost without restraint. In stark contrast, the arid interior demands endurance and size for survival. Larger animals thrive, traveling greater distances for water and storing energy more effectively. Over millions of years, these environmental pressures sculpt the bodies of the creatures inhabiting this land, setting the stage for the emergence of the great lineages to follow. As herbivores expand in size, predators evolve alongside them. You witness the rise of early reptilian hunters, equipped with long jaws and sharp teeth, adapting to match their prey in both strength and speed. This ongoing arms race of size and power paves the way for the Triassic, heralding the arrival of the first true giants of the Mesozoic era, the age of the dinosaurs. As you reflect on this fascinating evolution, consider the intricate dance of life that unfolds, shaping the world as you know it. Would you like to continue exploring this ancient narrative? In this early time, a clear pattern emerges. Pangea is a world that rewards adaptation on a grand scale. The supercontinent's interconnectedness plays a crucial role. Without oceans to obstruct their paths, species can traverse vast distances, carrying new traits from one region to another. A predator that evolves in one corner of Pangea can, over time, follow its prey into entirely different climates. Herbivores migrate from the wetter coasts to the drier interiors, their populations branching out and adapting to the unique conditions of each new area. Here, evolution does not unfold in isolation. It takes place on a continental stage. Every gust of wind, every seasonal shift, and every geological change sends ripples through this immense connected system. Though the giants of the future have not yet arrived, the groundwork is firmly in place. Forests are spreading, deserts lie in wait, and the atmosphere is undergoing transformation. In the quiet spaces between survival and adaptation, life prepares to grow larger, stronger, and stranger than ever before. Across the vast expanses of Pangea, the forests are unlike anything you know today. They are older, stranger, and filled with forms of life that have long since vanished from our world. Imagine stepping into the heart of ancient woodlands, where the very essence of the supercontinent breathes life into the atmosphere. These majestic forests anchor the soil and cradle a rich tapestry of wildlife, each creature finding its place in this evolving world. As you walk beneath the towering canopy, you enter a realm that feels both strange and familiar, a space where nature is still experimenting with the foundations of future ecosystems. In the humid coastal zones, the forests rise densely, their great seed ferns stretching their broad fronds toward the sky. These towering plants, neither traditional ferns nor flowering trees, dominate the landscape of Pangea, creating thickets so thick that sunlight struggles to touch the forest floor. Beneath their shade, smaller plants vie for every precious ray of light, competing in this dim green world. The air is heavy with moisture, and the ground is blanketed in thick mats of decaying vegetation, future coal seams waiting to be discovered beneath modern continents. Above the seed ferns, the early conifers stand as pioneering giants. These ancestors of today's pines, firs, and spruces thrive in a variety of climates, from the damp lowlands to the arid uplands that edge the heart of Pangea. As you reflect on this ancient landscape, consider how these ecosystems have shaped our world today. Would you like to explore more about these remarkable plants and their enduring legacy? You find yourself in a forest where strong, resilient trees stretch towards the sky, forming vertical layers that create a unique habitat. Among the branches, small reptiles and early insects seek refuge, their movements concealed beneath the protective evergreen canopy. As you venture deeper, the environment shifts. The climate becomes harsher and rainfall diminishes. Here the forest thins, giving way to drought-tolerant plants that dominate the landscape. Hardy conifers, low-growing shrubs, and cycads with their distinctive crown-like fronds stand resilient, as if they are echoes from a bygone era. These cycads flourish in a challenging environment where few other plants can thrive, anchoring the soil and providing sustenance for herbivores that wander into the arid spaces between the forests and the expansive deserts at the heart of Pangea. In certain areas, particularly near the coasts and river valleys, the forests merge with vast wetlands. These swampy ecosystems are ruled by ancient horsetails and club mosses, remnants of a time when they towered far above their modern relatives. Their hollow, jointed stems create dense thickets along the water's edge, with roots that secure the soil against the ever-shifting currents. These wetlands serve as nurseries of life, offering shelter to amphibians in need of water for breeding, while early reptiles patrol the periphery, hunting for their next meal. As you explore this rich tapestry of life, what stories do you think these ancient ecosystems could tell? The forests of Pangea are alive with sound. Insects fill the air with a constant hum, their wings shimmering in the dappled light. Giant dragonflies glide above clearings and riverbanks, their wings beating slowly. On the forest floor, millipede-like aeropods creep through thick leaf litter, while beetles and early ants engage in the quiet task of breaking down decaying plant matter. Every sound and movement forms an intricate web connecting the entire ecosystem. Where plant life flourishes, herbivores are never far behind. Early synapsids and reptiles browse among the ferns and cycads, their jaws designed to grind through tough vegetation. Some have squat, barrel-shaped bodies, housing powerful digestive systems that extract every ounce of energy from the fibrous plants of Pangea's forests. Their tracks, now preserved in stone, crisscross ancient floodplains that were once shaded by trees that have long since vanished. Even predators rely on these forests, though not for food in a direct sense. The dense vegetation offers cover for ambush hunters, and smaller reptiles and early carnivorous synapsids stalk the shadows, their movements concealed by layers of lush plant life. As you reflect on this vibrant ecosystem, consider the delicate balance that sustains it. Would you like to explore more about these fascinating creatures and their environment? Imagine a world where forests serve as both sanctuary and hunting ground, a vital space where every leaf and branch contributes to survival. In these forests, the air feels different, humid and heavy, infused with the scent of resin, damp soil, and decaying plant matter. Sunlight filters through, casting narrow shafts of light that touch the forest floor in fleeting patches. In the coastal lowlands, fog drifts in from the ocean, enveloping the trees in a soft mist that lingers until the warmth of the day dissipates it. As you move farther north and south, where the climate cools, the forests transform. Here, conifers take the lead, their evergreen needles uniquely adapted to withstand harsh winters. Although these northern and southern forests are sparser than their equatorial counterparts, they exhibit remarkable resilience, standing strong as the seasons shift. Across the vast expanse of Pangea, these forests weave a tapestry that connects the land. They trace the paths of rivers deep into the interior, stretch along the coasts, and ascend the foothills of mountain ranges formed from the continent's monumental collisions. Rather than a single, unbroken stretch, they create a network of green, uniting the supercontinent, enriching the air with oxygen, and shaping the evolution of its diverse creatures. Take a moment to reflect on the intricate beauty of these forests. How do you think they influence the world around them? As time unfolds, these forests become a stage for transformation. Climate shifts and changes in the Earth's atmosphere introduce new competition for the plants that have thrived in Pangea for millions of years. Yet, in this moment, at the peak of the supercontinent's era, the forests stand vast and untamed, laying the groundwork for a world yet to come. Life on Pangea is not merely inscribed in the forests and deserts. It pulses through the creatures that traverse these landscapes. This supercontinent is home to an astonishing variety of animals, ranging from the tiniest crawling insects to the formidable reptiles that will one day reign over the land. Each creature plays a role in a grand narrative of survival and adaptation, influenced by the climate, the atmosphere, and the interconnected geography of Pangea. In the humid lowlands and coastal forests, insects dominate both the undergrowth and the skies above. Elevated oxygen levels from earlier epochs have allowed them to evolve into forms much larger than most modern species. Imagine dragonflies with wingspans nearing a meter, gliding gracefully between the trees, their compound eyes keenly focused on their next meal, capturing prey with swift and precise movements. Isn't it fascinating to think about the intricate web of life that once thrived in this ancient world? As you reflect on these vibrant ecosystems, consider how they laid the foundation for the diversity of life we see today. You observe the steady and powerful flight of early aerial hunters, a testament to the supportive atmosphere of Pangea. On the ground, giant arthropods, resembling millipedes, creep through the damp layers of decaying plant matter. Some of these creatures stretch several feet long, their numerous legs moving in waves as they traverse the shadowy forest floor. They serve as detritivores, consuming fallen leaves and rotting wood, playing a crucial role in recycling nutrients back into the soil. Alongside them, beetles, primitive cockroaches, and early relatives of modern ants and termites create bustling microecosystems in the dark spaces beneath the canopy. These insects are not mere background figures. They form the foundation of Pangea's terrestrial ecosystems. They feed on plants, break down waste, and in turn become sustenance for the first small reptiles that venture away from the swamps. This is a world in transition. Amphibians still linger near rivers and wetlands, yet reptiles begin to journey farther inland, no longer reliant on water for reproduction. Their eggs, encased in protective shells, mark a significant step toward independence. Among these reptiles are early synapsids and diapsids, two groups destined to give rise to turtles, lizards, snakes, crocodiles, and even dinosaurs. As you reflect on this intricate web of life, consider how these early creatures shaped the world around them. Would you like to continue exploring this fascinating journey, or take a moment to rest? In the era of Pangea, you find yourself among small, cautious creatures. These beings hunt insects beneath the roots of towering seed ferns, or bask in the warm patches of sunlight that filter through the dense forest canopy. Their limbs are strong, their bodies low and agile, perfectly adapted to navigate the thick vegetation and uneven terrain of this ancient landscape. You notice the synapsids thriving as well. This group, which will eventually give rise to mammals, showcases a variety of forms. Some are quick, sharp-eyed insectivores, darting between shadows in search of their next meal. Others, like the early herbivorous synapsids, possess barrel-shaped bodies and robust jaws. They use their size for both defense and for processing the fibrous plants that flourish across Pangea, coexisting with amphibians that have adapted to life on land, yet still return to the water to breed, clinging to the vestiges of an older age. In the wetlands and along the rivers, amphibians reign as the dominant vertebrates. Some are small and nimble, their smooth skin enabling them to breathe both in water and on land. Others are formidable, crocodile-like predators, lying in wait with wide jaws and sharp teeth, ready to strike at any unsuspecting fish or reptile that ventures too close. As you reflect on this world, what thoughts come to mind? Perhaps you feel a sense of wonder at the delicate balance of life that has persisted through time. Take a moment to absorb this ancient landscape, where every creature plays a role in the intricate tapestry of existence. Imagine a time when amphibians are relics of an ancient world. In the lush, waterlogged environments along the coasts of Pangea, they persist for millions of years. Here, a complex web of life unfolds, intertwining amphibians, reptiles, synapsids, and insects. In the coastal forests, insectivorous reptiles thrive, relying on abundant insect populations. Meanwhile, amphibians hunt for fish and smaller creatures in the swamps, creating a delicate balance. Larger synapsid predators emerge, testing their strength against the other inhabitants of this interconnected ecosystem. Fossil trackways, preserved in ancient floodplain rocks, tell their stories. You can almost envision the small reptiles zigzagging between the imprints of lumbering herbivores, with faint trails of predators following closely behind. As you venture farther inland into the drier regions of Pangea, reptiles prove to be the true pioneers. Unlike their amphibian counterparts, they thrive without the need for standing water, following rivers and sparse vegetation deep into the continent. Here they evolve tougher skin to conserve moisture and develop stronger limbs for traversing open ground. Their behaviors adapt to a harsher climate, representing one of the earliest examples of life fully embracing the arid heart of Pangea, where rain is scarce and the sun shines relentlessly. What might this ancient world teach us about resilience and adaptation? As you reflect on these early life forms, consider the lessons they offer us today. Would you like to continue exploring this fascinating journey through time? In this vast world, insects follow their path relentlessly. Hardy species, resilient against heat and drought, spread across the arid landscapes. Termite-like insects begin to form colonies, burrowing into soil and wood to create sanctuaries from the sun's harsh rays. Meanwhile, the reptiles and early synapsids that hunt them evolve alongside their prey. Their movements reflect the delicate balance between predator and food. The forests, swamps, and deserts of Pangea intertwine not just through the land itself, but through the continuous dance of life that traverses it. Each plant nourishes an insect, every insect sustains a reptile, and each predator finds its place in this intricate web. The absence of oceans between these habitats allows animals and plants to spread more freely than they do today, transforming Pangea into a single interconnected stage where evolution unfolds on a monumental scale. In this realm, every creature participates in a grand experiment. Insects thrive in the oxygen-rich air, reptiles loosen their ties to water, and synapsids prowl through the shadows. Together, they form pieces of a puzzle, one that will eventually shape the Earth's future rulers. As you reflect on this interconnectedness, consider the profound impact of each organism in this ever-evolving narrative. What role might you play in the story of life? For now, you find yourself among the survivors of a world still on the path to balance. This is a world where the land is unified, the air feels dense, and life is poised to take its next remarkable leap forward. As life spreads across Pangea, a unique lineage of creatures starts to evolve, gradually taking on shapes and traits that will eventually lead to beings like you. These are the synapsids, often referred to as mammal-like reptiles, though they are neither fully reptile nor mammal. They serve as a transitional group, a bridge connecting the cold-blooded hunters of the past to the warm-blooded animals that will come to dominate the earth. In the late Permian period, the synapsids emerge as some of the most successful animals on land. They take on various forms, from small, sharp-toothed insect hunters to massive herbivores that rival the size of a modern rhinoceros. Their most distinctive feature is a single opening behind each eye in their skull, an evolutionary adaptation that allows their jaw muscles to expand. This seemingly minor change results in stronger bites, quicker strikes, and more efficient feeding compared to many of their reptilian counterparts. One of the most notable early synapsids is Dimetrodon, with its long, sprawling body and the impressive sail rising from its back. It resembles a creature pulled straight from the depths of imagination. As you reflect on this fascinating lineage, consider the intricate web of evolution that has led to your existence today. Would you like to explore more about these incredible beings and their journey? Imagine a sail that serves more than just an aesthetic purpose. It potentially plays a crucial role in regulating body temperature, capturing warmth during the cool mornings, and releasing it when the day turns scorching. In the unpredictable climate of Pangea, such an adaptation could truly mean the difference between survival and demise. Not all synapsids, however, are predators. Take the aviarous forms, such as the Daphosaurus, for example. They sport smaller sails and possess wide, blunt teeth, perfectly adapted for grinding tough plant matter. These creatures meander slowly across the floodplains and forests of Pangea, feasting on cycads, ferns, and other resilient vegetation. Their bodies are designed for endurance rather than speed, and their substantial size acts as a deterrent to the smaller carnivores lurking in their shadow. As the Permian period unfolds, new synapsids emerge, edging closer to what we might recognize as mammal-like. The therapsids, for instance, begin to showcase more advanced traits. Their strong limbs align more vertically beneath their bodies, and their teeth become differentiated for slicing and chewing. Perhaps they even exhibit early signs of whiskers or hair-like structures, although the evidence for this is still a matter of debate. These evolving features provide them with a distinct advantage. They are faster, more efficient, and better equipped to thrive in the diverse climates of Pangea. Isn't it fascinating to think about how these adaptations shape the survival of these ancient creatures? Imagine a world where formidable predators roam vast landscapes. Among them are the Gorgonopsids, sleek hunters equipped with long, saber-like teeth and muscular builds. These creatures stand as some of the top predators of their time, expertly navigating the dry plains and river valleys of the supercontinent Pangea. Their skulls reveal advanced features, hinting at a remarkable evolution towards quicker reflexes and sharper senses. In a world as expansive as Pangea, these adaptations give them an edge, allowing them to chase prey across long distances and seize every opportunity. Yet, alongside these fierce hunters, you find herbivorous therapids, like the Dinodons. These stocky, tusked creatures possess beak-like mouths designed for clipping vegetation and powerful jaws for grinding it down. Fossil evidence points to the possibility that some Dinodons traveled in herds, moving together across the landscape in search of food. Their remarkable adaptability enables them to thrive in both the lush coastal regions and the arid interiors, allowing them to spread across nearly every corner of Pangea. The remains of these mammal-like creatures are found on continents that today lie oceans apart, a testament to their resilience. What truly sets these creatures apart is their versatility. They are not confined to a single environment or lifestyle. Some flourish in the humid forests along the coasts, where abundant plant life and accessible water are plentiful. As you reflect on this ancient world, consider the intricate balance of predator and prey. and the remarkable adaptability that allowed these creatures to thrive in such diverse habitats. Wouldn't it be fascinating to learn more about their journeys? As you explore the vast arid heart of Pangea, you notice how life has adapted to this challenging environment. Creatures have learned to conserve energy, enduring long periods without moisture. Their extensive range allows them to thrive, making them one of the dominant forms of life across this supercontinent. Their success does more than ensure their survival. It transforms the ecosystems around them. As these synapsids evolve new methods of feeding and hunting, they push their prey and competitors to adapt in turn. This ongoing evolutionary pressure creates a dynamic world where survival hinges on keeping up with the relentless arms race of life. In this way, the mammal-like creatures of Pangea lay the foundation for traits that will define their distant descendants: warm-bloodedness, efficient movement, and intricate social behaviors. Yet, even amidst their dominance, the world around them is in flux. Volcanic eruptions send ash swirling into the air, while tectonic forces strain the supercontinent, subtly reshaping its landscapes. The atmosphere fluctuates, with oxygen levels rising and falling. Through all these changes, the synapsids endure. They are not mammals yet, but they carry the blueprint of what mammals will eventually become. Standing in Pangea, watching them navigate the land, offers you a glimpse into the early outlines of a future still hundreds of millions of years away. You find yourself immersed in a world shaped by powerful jaws and sturdy limbs, where survival is an art form. These creatures may not be the largest or the most fearsome, but their endurance marks them as the quiet architects of what lies ahead. In the relentless age of Pangea, endurance becomes everything. Beneath the vast expanse of Pangea, the Earth is anything but still. Its crust is engaged in a constant battle with forces that rise from deep within. Heat builds up in the mantle, driving the slow yet relentless movement of tectonic plates. Where continents once fused, the ground buckles and splits, allowing fire to emerge from the cracks. Volcanoes pulse with the planet's heartbeat, their presence an inescapable reality during this age. They are not merely isolated peaks scattered throughout the landscape. Instead, many rise along great fault lines where tectonic plates meet. These chains of volcanoes stretch for hundreds, even thousands of kilometers. In some areas, they erupt steadily, releasing rivers of lava that cool and harden into new rock. In others, their explosive power is sudden and catastrophic, sending ash and gases soaring high into the atmosphere, altering the climate for years. As you reflect on this dynamic world, consider the resilience required to thrive amid such extremes. What lessons might you draw from the endurance of these ancient architects? You can still see the evidence of ancient volcanic activity today. Layers of stone reveal the outlines of long-extinct volcanoes, while beds of volcanic ash lie buried within the rock, silent witnesses to the fierce forces that shaped our world. These eruptions were not isolated incidents. They were a regular occurrence on a restless supercontinent. The impact of this volcanic activity on Pangea was profound. Each eruption reshaped the land, carving out new mountains and burying valleys beneath hardened basalt. Vast plateaus emerged from layer upon layer of cooling lava, their surfaces later eroded by wind and rain into rugged landscapes. In the shadow of these volcanic regions, soils enriched by mineral ash nourished new plant growth, creating patches of fertile ground amidst otherwise harsh environments. Yet, volcanoes did more than just shape the land. They also transformed the air. Each eruption released vast amounts of gases into the atmosphere, including water vapor, carbon dioxide, and sulfur compounds. Carbon dioxide in particular acted as a potent greenhouse gas, trapping heat and intensifying the planet's already extreme climate. Over millions of years, these emissions played a crucial role in driving the temperature shifts that defined Pangea's environmental extremes. As you reflect on this ancient world, consider how these powerful forces continue to influence our planet today. Wouldn't you agree that the story of Pangea is a reminder of the dynamic nature of our Earth? Imagine a world where sulfur gases play a pivotal role in shaping the climate. When powerful volcanic eruptions send sulfur aerosols soaring into the stratosphere, they reflect sunlight back into space, creating a temporary cooling effect on the planet's surface. This dynamic interplay between volcanic warming and cooling results in a vast and volatile environment, with the climate shifting dramatically after each major eruption. Volcanoes bring fire too. Picture the forests of Pangea, abundant with resin-rich conifers and thick undergrowth, vulnerable to lightning strikes and the intense heat from nearby eruptions. Wildfires likely swept across extensive areas, clearing ancient growth to make way for new plant life. In this way, fire becomes an integral part of the planet's cycle, reshaping ecosystems and creating a patchwork of burned land and vibrant regrowth across the supercontinent. For the creatures inhabiting Pangea, these eruptions and fires present both threats and opportunities. Ash clouds can obscure the sun, disrupting plant growth and pushing herbivores to seek food elsewhere. In turn, predators follow, venturing into new territories opened up by the shifting landscape. Meanwhile, volcanic activity can also yield fertile regions where life thrives, demonstrating the complex and interconnected nature of this ancient world. Lava fields transform into rich soils, nurturing dense forests, while rivers, reshaped by eruptions, carve out new floodplains. One of the most striking reminders of volcanic power emerges toward the end of the Permian period. Massive eruptions in what we now call Siberia unleash enough gases to instigate significant changes in the atmosphere and oceans. These eruptions, known as the Siberian traps, pour forth lava over an expanse greater than many modern countries, sending shock waves through the ecosystems of Pangea. While this event signals the onset of one of Earth's most significant mass extinctions, it also highlights the profound connection between our planet's geology and its life forms. Even in less dramatic times, volcanoes provide a rhythm to Pangea. Their eruptions signify the passage of ages, with each layer of ash and lava serving as a page in the Earth's history. They remind us that beneath the forests, rivers, and deserts, the Earth is alive, a vast engine of heat and pressure that never truly rests. Imagine standing on Pangea during one of these eruptions. It would be a humbling experience. Ash darkens the sky, while lightning, sparked by the volcanic plumes, flashes in the distance. The air is thick with the acrid scent of sulfur, and tremors ripple through the ground, akin to the slow, steady breathing of the planet itself. When the eruption subsides and the sky clears, life emerges once more, revitalizing the land, reshaped by fire. Volcanoes, in their duality, serve not only as agents of destruction, but as vital components in the cycle that forms Pangea. They nourish its forests, sculpt its mountains, and transform its landscapes. They provide the supercontinent with a heartbeat, a deep rhythmic pulse resonating throughout the ancient world. For millions of years, Pangea existed as a unified entity. Its mountains, deserts, and forests extended from one horizon to another, all gathered beneath a single sky. Yet the very forces that brought it together from drifting continents never ceased their movement. Deep within the earth, heat from the mantle pushes upward, straining the seams that bind this great landmass. Gradually, almost unnoticed, cracks begin to emerge. These fissures do not appear suddenly. Initially, they manifest as rifts, long, narrow valleys where the crust stretches and thins under tremendous pressure. In certain areas, magma seeps into these gaps, giving rise to chains of volcanoes that signal the first signs of separation. Over millions of years, these rifts expand. Where the land once stood solid and unbroken, new basins form, foreshadowing the oceans that will eventually divide Pangea into the continents we recognize today. Isn't it fascinating to consider how these natural processes shape our world? As we reflect on this, we can appreciate the intricate dance of destruction and creation that defines our planet's history. As you explore the ancient rift zones studied by geologists, you come across scars etched in stone. In what is now eastern North America and western Africa, the rock layers reveal a history of gradual separation. Ancient faults map out the lines where the Earth's crust was pulled apart, while thick deposits of basalt narrate the tale of magma rising from deep within the Earth. These features serve as the earliest fingerprints of the Atlantic Ocean, even though the ocean itself would not emerge for millions of years. The splitting of Pangea is not a single moment. It is a process that unfolds in stages. Initially, the cracks are local, confined to long valleys that fill with lakes and rivers. As time passes and the crust continues to stretch, these valleys deepen and volcanic activity intensifies. Eventually, water from Panthalassa begins to seep into the widening gaps, signaling the fragmentation of the Earth's single landmass. Its edges slowly yield to the encroaching sea. As the land pulls apart, a shift in climate occurs. The interior of Pangea, already arid, becomes even more isolated as rifts deepen and mountain ranges rise along their edges. Meanwhile, the areas near the expanding rift valleys experience an increase in rainfall. This intricate dance of geological forces shapes the world, inviting you to reflect on the profound changes that have unfolded over eons. Would you like to continue exploring this captivating journey through time? The lowlands are transforming into fertile basins where rivers gather and forests flourish. Life follows these changes closely. Plants and animals that once roamed freely across Pangea now face the first real barriers in their world. Valleys, highlands, and expanding bodies of water begin to separate populations from one another. As Pangea splits apart, the winds shift as well. The edges of the supercontinent move, and new seas open up, causing atmospheric currents to adjust. Moisture from the oceans reaches new regions, while other areas experience increasing dryness. This process unfolds slowly and unevenly, signaling the beginning of the end for the single, borderless world that has existed for so long. Yet, even as the land cracks, life continues to thrive. Early reptiles evolve into new forms, some of which will eventually give rise to the first true dinosaurs. Synapsids adapt to the changing conditions, their descendants gradually developing traits similar to modern mammals. The forests ebb and flow with the shifting climate, while deserts expand and contract across the supercontinent's vast interior. The great breakup of Pangea will take tens of millions of years to complete, but its initial movements have already begun. You find yourself in a world where one land is gradually transforming into many. The continents we recognize today, North America, South America, Africa, Europe, and eventually Asia, begin to emerge from the first rifts, like a blueprint waiting to be realized. Imagine witnessing Pangea during this period. It's a land that feels both familiar and unsettled. You might sense the ground trembling beneath you, hinting at distant volcanic activity. Rivers could be carving deeper into rift valleys, expanding with each passing age. Mountains may rise as the Earth's crust buckles under immense pressure. This is a world in transition, its future continents quietly preparing to drift apart.